Alright, hello and welcome to example 2 from Math Foundations 20, section 5.4, the normal distribution. So example 2 here. Shirley wants to buy a new cell phone. She researches the cell phone she's considering and finds the following data on how long it lasts in years. So these are how long the phones last. We've got 2.0 years it lasts for, 2.3 years it lasts for, 1.7, and so forth. So she's got all this data on all of these different phones. Or sorry, on this one phone. This is all data about one phone. Okay, so the question here is asking, does this data approximate a normal distribution? So basically, right, are these numbers normally distributed? Right, that's the question. That's what we're being asked here. Okay, so first thing we need to do is find the mean and the standard deviation. Question asks for median as well. That's not really going to help us along the way, but the mean and the standard deviation definitely will. So first, if we calculate those, so I've got these calculated already. We could take those, use a calculator to do that, use online something to assist us, online like one of those links I put up to calculate the standard deviation and the mean. So the mean, which is x bar, or now, as I mentioned, is written like that as mu, is 2.526. The standard deviation, which has a symbol of sigma, is decimal 482. And the median, which won't really be necessary here, is 2.55. Okay, so does that tell us if the data is normally distributed? Not yet. Okay, next thing we want to do then is we actually want to draw a histogram of this and see, right, does this data look normally distributed on a histogram? So to make a histogram, first thing we need to do is make a frequency distribution. So basically we need to make a chart here of how long it lasts, right? So how long does the phone last in years? Right, and we'll have a column for a tally so we can go through that, and then a column to count up the tally for the frequency. Okay, so we do that, make a little chart here. Okay, one thing here is, what intervals are we going to use? Well, if we're going to draw a histogram and try and see if it's normally distributed, one good thing might be to make our intervals relate to our standard deviation, right? So make the interval here relate to this, so going up by that much, and we'd like to use our mean. So basically, we want the middle of our data to be 2.526. So I'm going to put 2.526 here, and I'm going to go from 2.526 up to 2.526 plus 0.482 to get 3.008 for this interval. And then I'll go from 3.008, I'm going to go up another standard deviation to 3.490. And then I'm going to go up another standard deviation, so 3.490 go up to 3.972. Okay, and then from the mean here, so from here, right, the 2.562, that's my mean. Right, I'm going to go and subtract standard deviation. So the one below it is going to go from 2.044 up to 2.526. And then go down another standard deviation. I'm kind of running out of space here, but I'm going to move that down. Okay, and then I have 2.044 minus the standard deviation, so I have 1.562 to 2.044. Move all of this down. Oh. Okay, I should have made this table with more room, but this will have to do. And then go down another standard deviation, so it's 1.08 to 1.562. Okay, so now what I need to do is go up to my data and tally this stuff. So I've got 2.0. Where does the 2.0 fall? Well, it falls in here. Okay, then I go 2.3, where does that fall? Well, it falls in here. Okay, and you could go ahead and do that and pause this video to do that. I'm going to jump up to the frequency. So, pause, do that. Hi, welcome back. Okay, so if you did that, the frequency we should have 1, 7, 17, 18, 6, and 1. Okay, so we get those values. So right now, we could even ask ourselves, does that look normally distributed? Right? Do we have the most data here at the mean? Well, yes. So the mean is right there. Right? Most of the data is in there. Is that 68% of the data? Maybe. Maybe it's close. Okay, do we have a small amount of the data at the ends? Yes. Right, so there's a good chance this is normally distributed. Right, so we can even get a really good indication there. Next step would be we could draw a histogram. So histogram here, I've got along the bottom how long it lasts in years. Along the side is the frequency, which is actually the number of phones. So I've got this labeled already, and I'm just going to make my bars for this. So the first bar for that is 1 high, right? So it's like that. The next one should be 7. So this is just going to be kind of approximate. So 7. Next one is 17. Next one is 18. No, this isn't looking so good. The next one beside it is 6. And the next one is 1. Okay, so now the question still is this thing normally distributed? It's definitely looking like it, right? It's looking like it's going to be normally distributed. We've got a couple more things that we can test to see. So this, if you could answer it from here, you could probably say, yeah, that looks normally distributed, right? It's not perfect. It's not that perfect, right, bell shape, but it's looking pretty good, right? So it's pretty darn close. Part 3 here says to compare the distribution of the data to the normal values of 68% within 1 standard deviation, and so forth. So basically, within 1 standard deviation, if we go back to the table, within 1 standard deviation that we have, right, down 1 is 17, up 1 is 18, so adding those together is 35. So within 1 standard deviation, we have 35 out of, and there's 50 phones there, so 35 out of 50 equals 70%, or 0.70. Right, so is that close to 68%? Yeah, that's close to 68%, so that's looking good. Within 2 standard deviations, right, what do we have? Well, within 2 standard deviations, we've got the 35 plus 7, so 42 plus 6, so 48. So that's 48 out of 50, which is 0.96, or 96%. And if we looked at our normal distribution, that should be 95%, right? So it's close to 95%. And we could have done the same thing with the last one. The last one, we'd find that 50 out of 50 of them are within 3 standard deviations, so 100%, which is close to 99.7%. So yes, it's very close to normal. So let's say yes, it's normally distributed. Right, so summarizing that, we've got 3 different things here. We've got the frequency distribution, which we can see these numbers, right, which give us a good indication if it's normal. So we've got lots in the middle, little at the ends. This here, right, that shape, right, it's pretty much normally distributed there. And this here, we're really close. We're 70%, which is close to 68, 96%, which is close to 95. Right, so yeah, this thing is normal. We could say it's normal. Okay, so I know this is taking a while here. Going on to part B. if Shirley purchases this phone, what is the likelihood, that should say likelihood, that it will last for more than 3 years? Okay, so more than 3 years. If we go back to this graph we drew here, right, 3 years is basically this line here. So 3 years is basically above 1 standard deviation above the mean. Okay, so remember that this in here is 34% of the data. Everything on this side is 50% of the data. So basically, we're looking for everything on this side of that, right? What is the likelihood of that? Well, we've got 50% there, 34% there, so all of this works out to be 84%. So then there's 16% of the phones are on this side. So answering that question, right, we're over here and we've got 84% of the data here, 16% of the data here, so there's a 16% chance, right? So basically 16% of the phones are going to last 3 years or more. So those are the chances she has. Okay, so I hope that was helpful for you, and remember you can always look back to this in a few days if you're still kind of having trouble with this. So thanks for watching. Have a good day.